NPU versus GPU versus CPU. What actually runs AI on your device? Your laptop has an AI chip, but what is it actually doing? A few years ago, most people only cared about two chips inside their devices, the CPU and the GPU. Today, there's a new acronym appearing everywhere, from smartphones and laptops to AI PCs and flagship tablets. NPU. Tech companies are promoting devices with 40 TOPS of AI performance, dedicated AI engines, and on-device intelligence. But what do these chips actually do? More importantly, when you use ChatGPT, generate an image, remove noise from a video call, or edit a photo, which processor is really doing the work? The answer is more complicated than most marketing campaigns suggest. The CPU, the brain of your device. The CPU, Central Processing Unit, is the general-purpose processor that manages almost everything your device does. Think of the CPU as the CEO of a company. It coordinates operations, handles instructions, manages memory, runs operating systems, and decides which tasks should be assigned to other processors. When it comes to AI, CPUs can run machine learning models, but they weren't specifically designed for them. CPU strengths. General-purpose computing operating system management, web browsing, office applications, app coordination, sequential calculations. CPU weaknesses. Relatively slow for large AI workloads, less efficient for massive parallel computations, higher latency when handling complex neural networks. If your laptop from 5 years ago runs an AI model, chances are the CPU is doing most of the heavy lifting and struggling to keep up. The GPU, the AI powerhouse. The GPU, Graphics Processing Unit, was originally designed to render graphics for games. Instead of a few powerful cores like a CPU, GPUs contain hundreds or thousands of smaller cores working simultaneously. Imagine a restaurant. The CPU is the head chef preparing one complicated dish at a time. The GPU is an army of cooks, each handling part of hundreds of dishes simultaneously. This parallel architecture turned out to be perfect for AI. Modern neural networks depend heavily on matrix multiplications and tensor operations, exactly the kind of repetitive mathematical work GPUs excel at. GPU strengths. Massive parallel processing, training large AI models, running local LLS, image generation, video rendering, scientific simulations. GPU weaknesses. High power consumption, significant heat generation, reduced battery life on portable devices. This is why companies such as NVIDIA became central players in the AI revolution. The same chips that once powered gaming now train trillion-parameter models. GPUs remain the preferred hardware for large-scale AI workloads. The NPU, the AI specialist. Enter the newest member of the computing family. The NPU, Neural Processing Unit, is a processor designed specifically for AI inference. Unlike GPUs, which evolved into AI accelerators, NPUs were built from the ground up to execute neural network operations efficiently. Think of the NPU as a highly specialized surgeon. It doesn't perform every task in the hospital, but when its specific expertise is needed, nobody can do the job more efficiently. NPU strengths. Extremely power-efficient, low-latency AI processing, real-time inference, excellent battery life, privacy-focused on-device AI. NPU weaknesses. Limited flexibility, not ideal for training massive AI models, requires software support, smaller workload compatibility. NPUs are particularly effective for face recognition, voice processing, background blur, live translation, AI noise cancellation, image enhancement, on-device generative AI features. Modern NPUs intelligently offload supported AI tasks from CPUs, freeing system resources while reducing power consumption. So which one runs AI? The truth is, all three do. Different AI workloads are assigned to different processors depending on speed, efficiency, and software support. When you use ChatGPT in the cloud, CPU manages the application, GPU powers the data center AI modeled, NPU usually not involved on your device. When you use AI background blur during a video call, CPU manages the application, NPU isolates your face in real time, GPU renders graphics if necessary. When generating images locally, CPU coordinates the process, GPU performs most of the generation, NPU may accelerate supported operations. When using AI photo enhancement, CPU handles the app, NPU processes enhancement algorithms, GPU assists with rendering. The future of computing isn't CPU versus GPU versus NPU. It's CPU plus GPU plus NPU. Why AI PCs suddenly need NPUs? If GPUs are so powerful, why are manufacturers rushing to add NPUs? The answer is simple. Efficiency. Running AI continuously on GPUs drains batteries and generates heat. NPUs provide longer battery life, instant responses, offline functionality, improved privacy, lower energy consumption. That's why companies such as Intel, AMD, Apple, Qualcomm, and Microsoft are investing heavily in dedicated AI hardware. The goal isn't replacing GPUs. It's bringing useful AI features directly onto your device. The reality behind the marketing. Here's something manufacturers rarely mention. An NPU only works if software actually supports it. Many applications still rely heavily on CPUs or GPUs because NPU frameworks remain fragmented across platforms. Some workloads even perform better on CPUs or GPUs depending on the task and implementation. In other words, buying an AI PC doesn't automatically mean every AI feature runs on the NPU. Software support matters just as much as hardware. The future of on-device AI. Over the next few years, we'll likely see a major shift. Cloud AI will continue handling the largest and most demanding models. GPUs will dominate training and high-performance local inference. NPUs will increasingly power everyday AI experiences. Smarter cameras, real-time translation, personalized assistance, AI-enhanced productivity tools, private, offline generative features. The devices of tomorrow won't rely on a single processor. They'll become teams of specialized processors working together. Final thoughts. If the CPU is the brain, the GPU is the muscle, and the NPU is the AI specialist. The real magic happens when all three collaborate. So the next time you hear a company boast about TOPS, neural engines, or AI PCs, remember, the future of artificial intelligence isn't about one chip replacing another. It's about using the right chip for the right job and making AI feel invisible, instant, and available everywhere. Quick comparison. In one sentence, CPU runs everything, GPU accelerates heavy AI and graphics, NPU delivers efficient, always-on AI experiences. CPU versus GPU versus NPU. How modern processors specialize in AI workloads. Processor. AI efficiency. CPU. 3. GPU. 9. NPU. 8. To strengthen the article for the AI hardware niche and target the keywords NPU, 71, AI hardware, 58, and how AI works, 67. Add the following expanded section after the Why AI PCs Suddenly Need NPUs chapter. Local AI explained. Hardware, setup, and models. Most people have absolutely no idea that the device sitting in their pocket or on their desk already contains a dedicated AI chip. If you bought a premium smartphone in the last few years or a new laptop in 2024 to 2026, chances are you already own an NPU, neural processing unit. And that changes how AI works. Instead of sending every request to the cloud, modern devices can increasingly process AI workloads locally, directly on the hardware you already own. This is called local AI. What is local AI? Local AI means running artificial intelligence models directly on your device instead of relying entirely on remote servers. Traditional AI workflow. Your device, internet, data center, internet, your device. Local AI workflow. Your device, NPU/GPU, result. No waiting for servers. No internet dependency. No sending private information into the cloud. The result is faster responses, better privacy, lower latency, reduced cloud costs, offline functionality. The future of consumer AI isn't cloud only. It's hybrid. What does an NPU actually do? One of the biggest misconceptions is that NPUs replace CPUs and GPUs. They don't. Think of your device as a team. CPU equals the manager. Coordinates everything. Handles operating systems, applications, and decision-making. GPU equals the heavy lifter. Handles graphics and demanding AI workloads. Perfect for image generation and large local models. NPU equals the specialist. runs repetitive neural network tasks efficiently, always on, battery-friendly, optimized specifically for inference. Intel describes NPUs as dedicated engines designed for sustained AI inference workloads while reducing power consumption compared with GPU execution. In practice, your NPU may already be doing things such as face unlock, background blur, voice isolation, live captions, photo enhancement, language translation, AI noise reduction, Windows Studio effects, without you ever realizing it. Snapdragon X, Qualcomm's local AI revolution. When Qualcomm launched the Snapdragon X series, it wasn't just building another laptop processor. It was building an AI-first PC. The Snapdragon X Elite features Qualcomm's Hexagon NPU capable of delivering up to 45 TOPS of AI performance, enabling on-device generative AI experiences. What Snapdragon X NPUs can do: run small LLMs, locally summarize documents, generate text offline, remove video call, noise, translate speech in real-time, power Copilot plus PC experiences. Qualcomm claims these NPUs can even run models with more than 13 billion parameters directly on the device. The focus isn't maximum speed. It's delivering useful AI while preserving battery life. Apple Neural Engine, the invisible AI chip. Apple has quietly been shipping NPUs longer than many people realize. The Apple Neural Engine, Yeni, debuted in iPhones years before AI PCs became marketing buzzwords. Today, every Apple Silicon Mac contains an Yeni. You use it every day without noticing. Yeni powers Face ID, photo categorization, series, speech recognition, live text dictation, image processing, accessibility features, on-device intelligence. Apple's approach focuses heavily on privacy. Instead of uploading sensitive information to the cloud, more AI tasks happen directly on the device. Recent research also shows Apple's NPUs can accelerate modern language models while improving energy efficiency compared with CPU execution. Intel Meteor Lake, the birth of the AI PC. Intel's Meteor Lake processors marked a turning point. For the first time, Intel integrated a dedicated NPU into mainstream consumer laptops. The technology is branded as Intel AI Boost. Meteor Lake distributes AI workloads intelligently. CPU, low-latency tasks, GPU, intensive AI processing, NPU, sustained low-power inference. Intel says this approach can significantly improve efficiency while maintaining responsiveness. Meteor Lake AI use cases. Windows Studio effects, background blur, eye contact correction, speech enhancement, productivity assistance, local inference acceleration. This architecture laid the foundation for what Microsoft now calls the AI PC era. How to set up local AI. You don't necessarily need a data center GPU. If you already own modern hardware, you're closer than you think. Entry level. Best for AI chatbots, writing assistants, small language models. Hardware. Intel Core Ultra Snapdragon X laptops, Apple Silicon Macs. Models. Gemma 2B, 3 Miniquen 3B. Mid-range. Best for larger local LLMs, coding assistance, document analysis. Hardware. Apple M Series Max RTX 4060 plus AMD Radeon systems. Models. Gemma 7B, Mistral 7B, Llama 3 8B. Enthusiast setup. Best for image generation, advanced agents or AG systems. Hardware. RTX 4090 class PUS multi-GPU workstations. Models. Llama 7EB, quantized, stable diffusion, XL Flux large RAG pipelines. TOPS, the new megapixel race. Laptop manufacturers love advertising TOPS. TOPS stands for trillions of operations per second. It's a measure of theoretical AI performance. But bigger numbers don't always mean better experiences. Factors that matter include software optimization, model compatibility, memory bandwidth, thermal limits, battery efficiency. A 45 TOPS NPU doesn't automatically outperform every GPU. It simply excels at a different type of workload. The biggest myth about NPUs. The biggest misconception is this: NPUs are not miniature ChatGPT machines. Today's NPUs are designed primarily for efficient inference. They accelerate everyday AI features. GPUs still dominate AI training, large model inference, image generation, heavy compute workloads. The future isn't about replacing GPUs. It's about giving devices specialized AI engines that work together. Why this matters. 5 years ago, AI lived almost entirely in the cloud. 5 years from now, much of it will happen directly on your device. Your laptop will translate conversations instantly. Your phone will summarize meetings offline. Your camera will understand scenes in real time. And most people won't even realize which chip made it possible. But now you know. Behind every AI experience, there's a silent partnership between the CPU, GPU, and the NPU, the hidden hardware that is quietly reshaping how AI works.